Hello, this is Mr. King. Welcome back. Today we're going to introduce Chapter 7. Chapter 7, Solving Systems of Linear Equations and Inequalities. Section 7.1 is our first lesson. Today we're going to focus on solving systems of equations by graphing. To get started, we're going to begin with a few terms. The first term is system of equations. What is a system of equations? A system of equations is a set of two or more equations that use the same variables. We'll get more into that in a minute. You'll be fine with that. I'm sure we will. Our second term is a t-table. T-tables are tables used to organize the x and y values. Okay? So what we do is we set up a little chart here. The x value goes to the left, the y value goes to the right, and the data we have here comes in ordered pairs: 4, 2, 5, 0, 6, and -2. Let's take a look at how a t-table will work. We're going to take a look at three equations. The first equation is y equals x plus 1. The second one is y equals the negative of x plus 3. And the third one is y equals 0 times x minus 4. So let's take a look at our first one. We're going to substitute all the same x values in each one of our equations. In the first one, if we substitute -5 in here, we get -5 plus 1 is a -4. -4 plus 1 is a -3. -3 plus 1 is a -2, and so on. We've now collected sufficient data that we'll be able to graph that equation and be confident that we have solid information to graph that equation. Let's take a look at the middle one. We're looking at y equals the negative of x plus 3. So we're going to substitute the same value in here. So if we substitute a -5, a negative times a negative is a positive, so that becomes 5. 5 plus 3 is 8. We substitute a -4 in there. A negative times a negative is a +4. +4 plus 3 is 7, and so on. So we get ordered pairs that look as follows here. So we now have two sets of data. Moving on to our third set of data, we are going to substitute the same value of x in here, but this time we're going to multiply it by 0. And 0 times any number we put in for x is going to be 0. And 0 minus 4 would render all of our y values as equal to -4. So we have all the data that we need to graph this properly. So we're going to graph these three equations on a coordinate graph. And I'm going to pull this in a little bit closer to make sure that you get it here. I'm sorry if it's a little wobbly. I'll try to hold it still. Okay? Notice we have all three of our equations listed right here. This graph here is the graph of y equals -x plus 3. This one is the graph of y equals x plus 1. And this horizontal graph is y equals 0x minus 4. But notice, where two lines intersect, they come to a single point. Okay? So we would find in these three intersections, we would find 3 points where the equations meet at the point of intersection. And we would identify this. This is point 1, 2, x equals 1, y equals 2. This is point x equals 6, y equals -4. And this point here is x equals -5, y equals -4. So let's talk about why that is important. Why would we go to all that trouble? Here comes our first VIC of this new chapter here. The very important concept we're looking at here is that the point of intersection of two equations is a common solution. We need an S in here. Two equations, okay? Let's take a look at our example. We're going to graph y equals x plus 1 and y equals x plus 3. Well, we actually did graph that already, and we said it came to the point of over 1 and up 2. What we're saying is the point where two lines intersect, right at that point there, and if we're saying that is 1 and 2, we would say that that would be a solution for both of these equations. Let's see if that's true. We're going to substitute a 2 in for the y and a 1 for the x. So 2 equals 1 plus 1. So 2 equals 2. That checks. So this point at the intersection works for our first equation. Let's take a look at our second equation. Y equals the negative of x plus 3. So we're going to put 2 in for y and 1 in for x. Only this time it's a negative. A negative 1 plus a positive 3 gives me a 2. Does 2 equal 2? Yes, it does. Therefore, point 1, 2 is the common solution for both of these equations. We're going to move on to a second video when we're ready that will discuss using a graphing calculator to help you do this work.